So here is our second day of solving equations. And again, I'm going to do two videos, one for the front and one for the back, because they're two different types of equations. And you'll see that all of these equations today do not start out with any logs in them, but we're going to use logs to solve. So when you see an equation that has an x in the exponent, that's when we're going to have to use logarithms, because remember, logarithms are exponents. So when we need to solve for that exponent, we're going to use logs. And you will need your calculator today for all of these problems. So everything we're going to round to 3 decimal places. And so for equations where you have just one x in the exponent, what you need to do is get that all by itself. And then after it's all by itself, we're going to rewrite in log form. So this is from your last test. Remember, this number becomes your base of the log. So we'll have log base 8 of 10. That number becomes our argument. And that's going to equal our exponent. So that's going to equal x. And now we just have to plug this into our calculator. And we know how to do that, again, from our last test. So this will be log of 10 over log of 8 equals x. And so now I'll plug that into my calculator and round to 3 decimal places. And we get 1.107. And you can always test this. You can plug it back in. You can take 8 to the 1.107, and you should get something around 10. It's not going to be exactly 10 because we rounded the decimal. We cut it off. If you would put that whole long decimal in there for x, then you would get exactly 10. But since we cut it off, it'll be something close to 10. But you can check that. Now, even if you have more than one thing in your exponent, we're still going to solve it the same way. So now I have a 6x there in my exponent, but this whole term is by itself, the exponential part, that's by itself. So again, I can rewrite in log form. So we'll take log base 3 of 7 equals 6x. So now here on the left side, remember to plug that into our calculator, will be log of 7 over log of 3. And so I'm going to plug that into the calculator. And when I do that, I get 1.77124 and so on. That's going to keep going. I'm not going to round just yet. We want to round at the very end. And now to get x by itself, I'll just divide both sides by 6. So that's going to end up being 0.295. And again, I rounded that. So if you're plugging that 0.295 back in here for x to check your answer, it's not going to equal exactly 7, but it'll be pretty close. Okay. And again, don't round this number here. Don't make this 0.771 because then you're not going to get the 0.295 at the end. So no rounding till the very, very end. So for each problem, you should only round once. If you're rounding more than once, then you're not going to get the right answer at the end. So everybody should be getting 0.295. Now, for our next one, this is the first one where our exponential is not by itself. So this piece right here, this e to the negative 2x, is not by itself. So the first thing I have to do is get it by itself. So I'm going to subtract 6 from both sides. So I have e to the negative 2x equals 9. And now the exponential part, where the x is in the exponent, now that is by itself. So I can rewrite this. So I'm going to have log base e of 9 equals negative 2x. Now, to put this into the calculator, I don't have to take log of 9 over log of e. Instead, log base e is natural log. So this is going to become natural log of 9 equals negative 2x. So now when I plug natural log of 9 into my calculator, I get 2.19722 and so on. Again, I'm not going to round that number. And now I'll divide both sides by negative 2. And I get that x is negative 1.099. And that one I did round. So again, don't round till the very end. You have to get the exponential part by itself first. So then you can rewrite in log form, plug it into your calculator, and solve for x. Okay? So the last one, we didn't do any yet that had addition in our exponent, but I still want you guys to maybe give it a try if you feel like it. If we were in class, I would have you try this one on your own. So if you want to pause the video and give it a shot to see how you do, you can. Or if you want to just keep following along, that's fine too. So my exponential part is this right here. This is where the x is in the exponent. Okay, and that plus 3 is in the exponent, so I can't just subtract 3 from both sides. If you notice the previous example, that 6 was not in the exponent, so that's why I could do that step. But this one is in the exponent, so I can't do that. But this is already by itself, the exponential part, so I can write in log form right here. So I'll have log base 4 of 5002 equals x plus 3. So again, to type this in my calculator, I'm going to have to do log of 5002 divided by log of 4 equals x plus 3. And when I plug that left part into my calculator, I get 6.1441 and so on. Again, I'm not rounding that. And now I just have addition here instead of multiplication or anything, so I'm just going to subtract 3 from both sides to get x by itself. So x ends up being 3.144. And that part, again, I did round. And again, you can plug that in up here to x and make sure you get, again, it won't be exactly 5002, but it'll be close. Okay, so that is your first type of problem where you have just one x in the exponent. So you get that part by itself, and then you rewrite in log form. Okay? I'm going to make another video for the back because they're a little bit more detailed because, as you'll see, we have two x's. So we have x's on both sides. So we can't write in log form because that's not going to fix both sides. That would only fix one side. So again, watch the second video to get the second part of these notes.